So I've got a PlayStation controller and an Xbox controller right here. I'm just going to jump back to combat. And I'm going to go to... Set the input number to 0. All right, so one thing that you'll see when you put in a... Let's clear all this. Okay. When you put in the... When you plug in the controller while Unity is active, if I can do that correctly, it will say, hey, it'll... Did it? Should be okay. There you go. So you joystick connected, controller, Xbox for Windows. Let's see. Hey, using. So this is where we are this week. A bug of the system is you can ram the other person moving around. So that's where we are right now. This week's lecture is going to be, again, I'm going to unplug this and I'm going to go to PlayStation controller, Xbox controller, second way. And you see that I've gone right to the other controller, no problem. The one problem with this method of what we're doing right now is that we're dealing with only one controller right now. So this is great for single player stuff. But the moment we need to add another controller into our mix, we're going to have to do some much more sophisticated techniques. Probably we'll talk about that in a few weeks. It'll be a I think I'll probably make this a supplemental lecture when you start doing your projects. And that's something I should warn you is that, hey, you do have a project at the end of this course, and it's some small mini game. Now, I think it's something with the cord. What's this all about? Weird. Okay. So I'm having a weird error with the PlayStation controller again. It's a PlayStation 4 controller, so. But all right, so let's talk about Raycast. I don't have the slides, but basically, in a nutshell, what we're talking about is a line in space. That's what essentially a Raycast is. It is you have a origin, you have a direction. In theory, when we talk about, so there's a concept of array. An array is a line in space. You have a vector that is a vector 3 that is where you start, your origin, and then a vector 3 that's going to be or quaternion that's going to be the direction you're going off in. By definition, rays go off into infinity, but infinity, as much as infinity is cool, there's a practical limit to, ideally, we don't need to go off to infinity to do our work. And so one of the first things you will see is that when you start using a raycast, is that you typically are going to have some sort of limit to the raycast. And for our purposes right now, we're going to go about 50 units out, 50 to 100 units. That will do everything that we need effectively in our arena We'll start with 50. If not, we'll jump up to 100. 100 will definitely get us everything in the arena. But the idea here is that we don't need to go off to infinity. You know, we don't need to, like, if there's something way off in the distance and it's like, we don't need to worry about it because it's not relevant to what we're doing. So that's practical things that you are thinking about in terms of the Ray and Raycast. The other next thing to think about is that when you do a Raycast, you get information back, and that is in form of a Raycast hit. And we'll look at that structure in code in a few moments. So let's jump back to on Canvas. There is a package that has an example for Raycasting. All right, so I'm going to go into this example. And we'll look at these again. Spin control, it's just spinning. It's a spin script, so effectively. We'll look at the Raycast example, and we'll look at the Ray example script. So we'll jump in. Don't save. I don't need to worry about it. And you can see right away that when we go to the console, my point is 13 is an array. That message came when I loaded the map. It came. We will look at that in one moment. So let's start with the Ray example. Let's start with working with rays. And you can give the structure of the Ray as a variable to the Raycast attack. So one of the things that we've got here, I want to point out right now, is this execute in edit mode. And so what we're starting out dealing with, you can set metadata information. So for this class right now, this script, it is running actively in the editor. And let me see, it's trying to debug Ray. So let me go back and let me make sure. Here's the Raycast example. Yeah, so it is doing that drawing. So there's a red line right here. We can see in the game view. We go to game view, we don't have that view. And one of the things we'll do during this lecture, I'll show you how to set that up, what you should do in the game for something that you're going to look at in the game world. But moving on. But right now, this is so what we're looking here is a debug line. So let's look at the, close all these. There we go. Make this bigger for you. So when start is called, so basically when the level got loaded, start got called right away. And we have this Raycast example code. And right now it creates an array that it gives you the origin. Right now we're going to set the origin at 0, 0, 0. The Ray direction was forward, so it's going to be 0, 0, 1. And then we want to get a point on the Ray at 13 units out. So it's going to be 13 units times its forward direction, which is going to be 0, 0, 13. So 13 points on the Ray ends up being the point to string. So the point ends up being 0, 0, 13. In update, we have the draw debug Ray. And we could have, in execute and edit mode, we could have dropped that down to just update. It will not reprocess. So that will instead clear out the window. This might only be, sorry, this is a class metadata thing. Yeah, there we go. Okay, so the big thing about this is that the function that you're going to use is off the debug, and it's draw Ray. Now this is only again going to be in your scene view. It's not going to be in your game view. So this is great for debugging. If you wanted to see something like there's a lot of cases for animation pieces, and if you're doing attacks based on animation, then you'd be using the draw rays to help figure out what's going on with that animation, that animation attack. Again, we have a draw length of 25, and again, we start with PlayStation controller still connected. My apologies. All right, so we're going to say only that the ray that we're going to cast is only 25 units out. And for what the little clock thing that I've set up, that's perfectly fine. The origin is going to be the game object transform.position. So the origin of this, so this is on that center piece. So we're using its position as the origin. And then the direction is the origin plus the transfer.forward plus draw length. So effectively, there we go, extra thing. But that effectively, basically, direction ends up being the endpoint in this case. So it does call, it says direction, but it's not just, this is a quirk of how Unity works. It's really not a direction, it's really the endpoint of the ray. And then draw color is going to be red. And that ultimately we're going to set up, here's the origin, the direction, draw color. Let's go through this just quickly. Let's look at some of the other overloads. So you do a start in direction. You don't indicate what color. Let's go down. Here's the one that you're using, start direction color. Start direction color, duration. So this is how long the point is, how long the ray should stay. So if you wanted this more than the default, then you say I'll let it stay for a second. And then finally, def test. I'm not really sure what def test is doing, but I've actually never used the def test for my purposes. But I've used duration a couple times. Actually, duration if you want the ray to stay longer than a single frame. So again, the version that we're going to use is this version right here. Start direction color. Why would you set this up? Because this is going to be helpful for you. Ultimately, this is going to help you indicate where is my where am I excuse me, where am I looking at and where am I shooting from, for example. So let's I'm actually going to take this debug draw ray and let's jump this back to the combat controller. First thing I'm going to do is I'm going to put a public float raycast distance. And we'll start this with 50 units. I'm going to drop this in here. So we don't need to use the draw length. What we want is not draw length, it's now our ray cast distance. And then the other thing is we're not going to use the game object. Here's the projectile spawn point. That's the. So I can go in and I can just take out both of these. So it's not to be the game object that transform. Will be our projectile spawn point. That makes sense. It's where we're attacking from. And now that I've got this, I can just drop this into update. So this won't show in it won't show in the editor, but when I save, let's go back to Unity for one moment. Let's see, let's go back to combat. Don't save. So I'm gonna get some more room. Put the game here. So when I press play, you'll then see position. That should give me something wilder. Did they fix it? They did. Okay. So it looks like something got fixed with the latest version of Unity. Okay. No, we don't need to worry about that now. So it's now just actually the distance. It is the vector, but it is based on distance. So let's go in and let's look at, again, we'll go to raycast distance. We'll just do 10. This one, you can see that. Boom. So it's much smaller. I think 50 gets us everything. Let me just check. So 80 is more close to what we need to make sure that we're getting everything. So give you, if you wanted to like do something smaller attack, you can. All right. I got to bring up an odd example of a raycast attack. It comes from Half-Life 2. And in theory, the crowbar is a raycast attack. It has a range of like 1 foot ahead of you. It's like super, super small. But it is technically a raycast attack. Let's bring the volume down to get that out of the way, so it's not playing over me. Yeah. So again, example of raycasts. They're all over the place. They're used for so many different things, like AI vision in a world, in AI in a game. An agent basically would be like, I'm going to use one or multiple raycasts to determine whether I can see something. All right, so usage, and we're playing with usage and whatnot, looking at the debug ray. Let's go. Let me just jump back here. I'll make sure this is 80 as well. It's 80 as well, and save the scene. Okay, let's jump back to that raycast example. All right. I'm going to use this version for right now. I'm going to use the scene view for right now because we got the debug ray. Let's press play. And we click on the center here. This is what it's looking for. It's basically right now, it doesn't have any hits. And it's basically found cube 1-1. So right now it's just finding I'm going to pause. And we're going to go zoom in and look at this as it steps through. So, come on. There you go. So you can see now it's finally overlapping with there. It hit at this point right here, 95.47 off, normal. Here's the hit at normal. So if I wanted to put something there to indicate the hit, I would want to basically rotate it like this to get the correct rotation for what I want. Next thing I can do is I can tell it to check for all hits. And I'm going to move... so I can collapse all these. I'm going to put this at the bottom so I can collapse, so I have enough space. So now when I do the next I'm going to go a couple more times. Now you can see that I can look for not just a single hit, but I can look for multiple things on that. So right now, it's going through cube 3, 2, 3, 3, 1, 3, 2, and it hasn't hit 3, 3 yet. And that's, again, function of distance. What's going on here? And now you can see that it's now hit 3, 3. I'll unpause it, and it goes, and off it goes to the next group. So again, you can see right now. The thing that you do have to worry about is that when you have multiple objects, it might return. Right now, it's found 5.2. It should return at 5.1, but we'll talk about it in a moment. I think this is because I've got multiple. Yeah, I think how it's being ordered right now. It should normally this found object is being fielded a different way. So just note that not every object, if you got multiple objects, you look at multiple, it's not sorted by distance, and it probably should be, but just to know that that's an issue with what you're dealing with here. Let's jump into the code itself now. All right, so here are all the booleans and the public stuff that I'm showing. And again, the big thing here is the only one that matters the most for you. Let me put this up here. All right, this is the only variable that you absolutely have to do your work. All of these here are here to show you information when you have a raycast to hit. And if you look right now, the first thing that I'm doing is I have two functions. I have multiple raycast hit and single raycast hit, and it's based on that boolean. You would not do this. All right. Why is that? There we go. So that's what the code. Why is that weird? There we go. So that's what update is doing. What we are going to do is that we are going to, when we press the raycast attack button, it does the raycast, and then looks for what we need. All right. I have this utility function, reset editor publics. You would never write this because this is just a utility function to clear the editor for me. I also have a process utility hit. It takes a hit and it puts information into the editor for me. Again, you would never do this. You would never write this. The big thing is that when you do a raycast, first thing is you need to create. So for we're doing a single hit. You need to create a variable, but not initialize it. And the reason for this is that we're going to do something funny. It's an old school trick. We're using an old school technique, and I'll go over that one moment. But here is physics.raycast is the function that you're going to use. Conversely, physics.raycastAll is the one, if you want multiple hits, is what you're going to use. All right, so physics.raycast returns back a Boolean. It only turns back so the Boolean is you have hit something or you have not hit something. Now, we can check if has hit, then we can look at, so if this Boolean is true, then there's information here for us to use. You will see this if it statement, like with the physics raycast, with all its, you will see that regularly thrown into the if statement. I'm not doing it because this is easy to read, and it makes more sense ultimately. If you're doing an optimization and all that, you know, and you needed that memory space, then cool, take that out, throw in the if statement. But I'm doing for readability. Let me break this down. So that you would not normally write the code this way. All right, so this is one line of code. So the first thing is where are we basically, what's our origin? Next one is the direction. Again, these are relative to our transform. This is technically game. Technically, this is really what we're doing. You see check distance. Again, here's the out. So here's the weird thing that's going on. When we look at a function can return back a single value. And in the world of physics, basically it became a regular practice to create a structure to do your work in, but to return it as an out value, which means normally when you provide a value to like a structure to a function, it's read only. In the case of the physics object with the out variable, it now becomes read write. More in this case, more it write because it's going to write everything. This is old school programming. It is legacy programming. It is not. This is not used often, but it's here. It's here, so you have to know about it. So when you're doing the raycast, don't forget to put on the variable for the out. Make sure you do have to put the keyword out next to the variable name in terms of processing it properly. And if you don't do that, it's gonna yell. It's like can't convert. So it's trying to basically use a different version of the function. So let's go over again. Let's go over physics.raycast. And there's 16, and then you can give it array. You can give it an array with max float distance. Here is array out with again. Here's the out variable. So again, here's the hit info. You can just give it an origin and direction, and tells you that you did get a hit. Max distance, layer mask. So layer mask refers to layers within Unity. Here's the array, vector origin, max distance, origin distance, raycast info with an out variable. I think the next one is, that's not what we want. This is the version that we're using: origin, direction, raycast info, out, max distance. So this is for our purposes, like what we're going to do regular day in, day out. But I'm showing these other versions because they're there. Let me delete this. Okay. So we have a hit. We can process the hit. Let's go down process hit. So has found object true. That's something we're throwing in the rear. But hit has whole different things. So hit collider. The physics piece that we actually hit. So again, you can go here. What we'll end up doing is like hit game object, and then we can do ask get component in, and we'll just for the sake of argument right now, get component collider, but it could be combat player or combat controller. There we go. So this is legit code. This is in the information of hit off the collider. What is the game object? And then it would actually be get component in parent. So this right here would, if you hit a player, this would return back the combat controller. Hit normal. And this is going to be a vector 3. So it's the normal surface of the ray hit. Hit point. You know, the impact point in the world space where the ray hits the collider. And we'll use the normal and we'll use the point when we set up the raycast hit. Hit. What else does it have? If it has a rigid body, what's the transform? These are the big ones. I don't know what an articulately body. I haven't used this. Collider. I may have used it a couple times. Distance of the ray's origin to the impact point. We'll actually use that. Actually, we'll use that to our advantage. Light map. This is like information about what the UV light map coordinate on the impact. Again, normal point, rigid body, texture coordinate, transform. The index of the triangle that was hit. That's more mesh information. Yeah, these are all not stuff we don't need. Yeah, but again, the information's here. I mean, just go do hit dot and look through. Again, normal, rigid body, transform, point, collider, distance. These are the ones that you're going to use on a regular basis that you're more concerned about. So hit at point, hit at normal. This is just showing information. Again, let's go through. So in the case of the multi, so basically it is pretty much same thing, transform position, check distance. The difference is that raycast all is going to return back an array of raycast hits. So we're going to do a raycast hit array hits. Hits is equal to what we get back. So better programmed. And for my purposes, I'm going through here and I'm basically going to process the hits. So again, the last hit is what I'm going to get shown. But basically, I'm going through found object list, add the object. Again, I'm just adding the object name to the list because let me just check. Yeah, it's just a list of strings. So that's what I'm not adding objects. I'm just listing a string based on their name. Not what you would be doing. You would probably be like putting in the colliders or looking for or asking for each of them. Are you something I am concerned about? You know, is it a particular game object type or do you have a script on you before I add? So this is just note that you would not do this in normal. This is just showing you what got hit on the editor, quick and easy. So again, the big one is that we are going to use the physics raycast in our assignment. So now that we've established that, I mean, I'm actually just going to grab all of this right now. I'm literally just going to jump back into my combat controller. And we can go down to the raycast attack. Bring this all the way back. There we go. So we'll keep the audio going on right now. I will paste this in. And again, the first thing is not check distance. It's going to be raycast distance. There we go. And then we're going to take this out. Reform this a little bit better so you again, this wouldn't be game object transform. Again, this would we're going to our let's go up here. There you go. Expect spawn point. Again, remember we set this up to be a transform, not a game object, so that we could access the transform pieces quicker. Here is out hit, raycast distance. Again, this is literally what you need to write to get this working. Now that we know that we've got a hit, the first thing that we need to know is you hit again. So we want a combat controller CC. So we're going to ask, did we hit another player? That's and we know it's a player because it has the combat controller script. Again, this is going to be hit dot collider game object. So I'm going through the collider variable to get to the game object piece here. So just this is how we're weaving through this. But you've seen this before. You've been given a collider before. That's the the trigger. This is just one more step to get before we get to the collider that we want is one step. So game object, get component and parent, and then combat controller. I hit tab to complete the line, and I'm going to go. So that's the first thing, is that, hey, ask if the object has a combat controller. And if CC we've hit a player. And for our purposes at this point, if we go look at the basic projectile, I mean, what we're doing is basically, debug log, hit a player, owner.kill. So in this case, we don't need to do the owner.kills because we're the owner. We'll do this. So this refers to the instance of the script that's on the game object we're talking about. So this is for player one. So in this case, kills. We could also just do kills. These two lines of code are the same thing. This, when we don't put this in front of it, it's implied that this is implied. I'm showing you excuse me, too many this in action here. I'm showing you, I'm showing you this, my apologies, because there are certain coding styles where you are required to use this in your code. And that's because they want to make sure that that there is no ambiguity about what variable are you referring to. And it's a coding, if you are required to use that coding standard, that will be in a document for your team. And I've seen reasons for it, and I've seen reasons against it. I've seen friends complain about that they have to use the this keyword. And they're like, why do I need to? This works. It's because this is a coding standard that the team, it's because the coding standard, and if you are required to use that particular style of coding, there is a reason why and a story behind it. You should know it. That's all I'm going to say. You should know it. I'm not going to require you to use this in your code. I'm perfectly fine with this line of code. In fact, I'm going to take this out. Now, the thing that I want you to be aware about is that we still need to go cc.reset. Reset the other player. Okay. You might do something like this. Just call reset. Remember, effectively you've done this dot reset, which means you have gotten the kill, but you are resetting yourself. That's a mistake. So just be forewarned. Make sure you're calling just make sure that you are calling the other player. So far so good. Let's go have some fun. Let me just check. They have a death. Let me see. Location, game object, death decal. So I'm gonna just drop in one more thing right here. This would be public game object. We'll do a raycast decal. And then what we'll do is after the projectile. So we do want to have a hit. We do want to, again, create what's going on? Wow, I can't type today. What am I doing wrong? Instantiate. There we go. All right, so this is going to be the raycast decal. Again, I want to go to the correct version that we want. And we're just going to do a position and rotation. In this case, it's going to be hit dot point and hit dot typically normal is what you're gonna end up using. And this is yelling because it's looking for a quaternion. So luckily for us, there is it off quaternion? Let me see. Did they give us? No, it's not there. Okay, it's in the quaternion. So there is a Let me grab this out of the way. Quaternion. There we go. So this is going to take, so basically what we want to use is a function off the quaternion class called Euler. So it takes a Euler angle and converts it into a quaternion. And there are two versions, a vector 3 Euler and then the XYZ. So again, we're going to use the vector 3. So that is going to be our hit, not normal. So why is it yellow? Oh, we need another. There we go. That will make more sense if I put in these spaces. So we're going to use the quaternion class to take the vector 3 as a Euler coordinates. Again, Euler is basically a vector 3, and it's going to convert it into the quaternion for us. Save. We may come back, and this might not be what we want. We'll take a look at this. So we're going to do it this way. The other answer might be, because we're in that top-down view, the other answer might be identity. So we're not going to spawn it with a rotation on it. And that's ultimately because the normal is not what is putting it in a direction that we don't want. So I'm going to comment this line out for right now. We'll do the first one. We'll come back. We'll know right away if this is wrong. But what I'm afraid is that the object is going to be rotated with the ray and not straight up, top down is what we want. So let me just make sure. Yeah, it's called. So I mean, this is pretty much. This is the big piece is right here. This is again extra to make our things look good. So let's go back to Unity. And I want to just make sure, yeah, this has a box slider. I want to turn that off. And I want to grab, where's the lifetime? Let me lock this for one moment. And then let's go back to there we go. So we unlock this one. Okay, so we want to do 2.5. So let me, I didn't do the white one. So we're going to use yellow for the raycast attack. And this will be, again, another 2.5 lifetime. Just so that, you know, for consistency's sake. Let's jump. Let's open scene. Make sure that this is now assigned to player 2 before you go on. And then we will save the scene. Press play. And let's go to, you can see. So what I needed to do, we look at this one, we needed to make this bigger. So let's go 2.5, 2.5. There we go. And you can see where those are hitting. So we go push the player. You see that again. Do them again. We'll use the projectile. Now we can hit. We can, in theory, hit those projectiles. Right now, you know, I can hit them multiple times. So let's have some fun. Let's say the raycast attack hits the projectile. Let's kill it. So that's just going to be another set here. This is going to be a basic projectile. Let's call it projectile. And I'm just going to grab this line of code. Instead of a combat controller, it's going to be the basic projectile. There we go. And I'm just going to basically bring that in just so we can see everything. Again, don't in your code, don't do this enter. I'm going to leave a note for you here. If you break your line like this in your code, you will be docked. Again, I'm going to put this comment here up here as well. Again, if you're gonna don't follow what I'm doing. I'm doing this so you can see this on screen. This is what, again, I'm going to go scroll a little bit. This is what the line of code should look like in your code. It's how you should write it. In fact, actually, this is... Yeah, to the ones in the string of. So again, so basically we're just asking, hey, one of the things that we can do, just before we go on, yeah, no, we can just continue. So if we get a projectile, and let's just check. Look at basic projectile. On trigger, enter, reset. So what we're going to do to make our lives easier is we're going to basically make a new function here. It's going to be a public void on, let's call it on death. And I'm just going to take the on death function, put it here, and then the only thing that we do need is just these 2 lines of code down here. And that will make our life easier, so we don't have to rewrite that code. So think of if you've got a singular action that removing the projectile. In this case, removing means one, placing the death decal, and then 2, destroying the object. So now that we've done that and we've made it into its own function, what we can now do, go back to the combat controller, we can just go projectile on death. And this is starting like, hey, we create a function to do something. We created another function to do something. We created another function to do something. And we made these particular functions public that we can call from outside of the class. In this case, we're telling the projectile, you're dead. So where before we were shooting the projectile over and over again, this case, when we hit the projectile, we're gonna remove it. So save. Let's jump back to Unity. So the big question now is, when I hit them, I'm getting 2 different death decals. Should I have one or should I have both? Let's say, for sake of argument, it might not be what we want. Let's go back to the death. Let's go back to the death. Let's go back to the projectile. So there's a concept when you write functions that you can write a function with a parameter and has a default value. So if this is the case is bool drop death decal, and we can say true equals true. There we go. We don't need to do, so if there was another property. Now, these have to be so these are called optional parameters that you can set them up. In this case, I mean, what we want is if drop def, and we should say as a form of question, it is dropping death decal. Again, right as a form of question. And then we're just going to grab that 1 line of code. Now, as it stands right now, because I made this an optional parameter, all the on deaths, like again, up here on death, the on death in the combat controller, they're all perfectly fine because they're going to assume that, again, we go look over it. You can see right now, it's going to assume that that value is going to be true. So let's just go through that, save everything, jump back to Unity, and you'll see that that effectively has not changed anything because we're so we're still right now. This is the case. In the case of our combat controller, we can now go and type in false. And now we'll pass that false value to this function. And it won't drop the death decal in this case. We can go back to Unity. Did I not? Oh, I did it in the wrong. sorry, wrong place. I want to do it in the combat controller. Oops. Sorry. I turned off all the, I turned off the on death on no projectile in general. This is where I wanted to do it. My apologies. So let's go back to Unity now. Close the hub. Press play. Yeah, you can see that. Hey, hooray! So, polish, things to consider. So let's get into setting up a. We're gonna create a. What we're gonna do is we're gonna make the laser be viewed in game. So we'll start with player one. Let me stop the editor. So again, right now, you can bring this up. So that's nice that we can see this in, in the editor, in the scene view. Again, we can go. You can see that those are in action. It is. So let's have a laser flash. So this is solely a visual component. So there won't be any colliders. So we'll start with tank controller. Yeah, I'm going to build an empty game object off the fire point. And this is going to be the visual laser. So this is going to be the root of the visual laser, and the script for it will be here. The first thing that we'll do is we'll go in and we'll add a 3D object of a cylinder. This is going to be the laser model. So we got some work to do here. So the first thing that we now need to do, let's give it. Go to, where's my comment assets? There we go. Pure. So I'm going to make this red for obvious reasons. First thing I'm also going to do is rotate it 90 degrees on the x-axis, and I'm going to go back to here. So again, the forward direction. So the direction that we're concerned about is the Y. I'm going to bring in 0.5. 0.5. I'll do 0.3. So here's what the laser's right now starting to look like in game. The problem that we have right now is that it is underneath the barrel. That's not what we want. Also, the origin is at the center. So if we make this, size of 2, it's scaling not as we would expect. So we're going to leave this back as 1. What we are going to do is move this forward. So this is going to, again, because this is so we're going to move, I believe in the, let's go to a global. So it's on the z-axis. So we need to move this, I think, half a unit. No, we need to move a whole unit. There we go. So what this is telling us right now, I believe this is a size of, I believe we have to make this 0.5. So let's move this 0.5. I believe the length of the capsule is a unit of 2. Because because if I'm size, this should be the correct size. So this should be a length of 1. So what we're going to do, what we can do is we can scale. If I do a scale 2 here, That's not the one I want. Z is what I want. So Z is our forward direction. So basically we can scale 3, 5, and let's do a length of 10. I'll do a length of 9. We'll just, and this will give us a scale 1. Here's our game view. Actually, I don't want to look at my game view. Scale 1. There we go. So what I'm going to do right now, I'm going to just do scale 9. I'm going to press play. You'll see there'll be like we've gone 50. I think 50 units. So let's just, for the sake of argument, go 50. So the problem that we have at the moment is that, well, the laser model has a capsule collider. So we're gonna stop and let's remove that component. So let's jump back to the visual laser, press play, and then we'll make the laser model. We'll make that 50. Did I get it? I go 100. Oh, I did set the value to 80. There we go. There we go. So there we go. I had thought 50. Again, there is, you can see, all the way to 50. We'll go to just now 79. You can see there's a 1 unit off. All right. So we know that we can scale this object, and this will scale appropriately. So let's go back, set this to 1. We are going to get a gap. I mean, the only way to fix that is to play with where the spawn point is. I mean, we could pull this back. We can, again, make sure there is no collision on this, again, on the capsule collider. So, you know, it's polish, effectively. I'm not going to worry too much about that at the moment. All right, so let's build this script. Let's go to combat, and let's make a new script. It's going to be laser control. Okay, so laser control. Let's jump into it. So first thing, we'll stop. Let's do this again. Laser control. Okay. So first thing that we'll want to do, you see, start. I don't think we need to do anything in start, but we'll leave it for right now. Update we will use. First function we'll want to write is we'll do a set. This will be a public void set distance. Float. We'll use value. And this is basically what we're going to do is basically going to, we do a vector3 scale, new scale. It's going to be vector3. This is the case we're going to use vector3.1. Because we want, you know, the x and y to be 1. It's only the z that we're going to change. So ultimately, this is going to be new scale dot z is going to be equal to our value. And then game object transform local scale is equal to new scale. So hooray. So we have a function that we can use to set the scale. Get that out of the way. Next function is we want a function public void start laser. And then we'll do a public void hide laser. Okay. So first thing that we do want to know is we want a public, I can spell public game object. This is going to be the laser object. And in start, we're going to just say hide laser. So we'll hide it by default. In this case, when we start the laser, we are going, one of the last things we're going to do, laser object, set active true. And then down here, when we hide the laser, set active is going to be equal to false. I am going to just put a float distance in here. So again, I'm going to call set distance, that distance value. I am going to grab this right here, and I am going to say, for the sake of argument, when I hide the laser, you don't necessarily do this because I'm hiding it, but I'm just going to, for the sake of being clean, do a vector 3.0. Oh, sorry, not 33.1. My apologies. Oh, yeah. Conversely, yeah. Yeah, I'm just going to set, I mean, conversely, I could have done set, the alternative is actually, let's just use that function. What we really want is set distance 1. F. There we go. So this is all cleanup stuff. So how we know how this is going to work is basically we're going to have a public float. We'll call it showtime. I'll do 0.3f. I'll do 0.5f for right now. And then there'll be a float showtime counter. That will, obviously, will be 0. And so what happens is what we'll ask is if the showtime counter is greater than 0, laser is active. And so what we need to do is essentially, again, we're going to do a showtime counter is minus equals time dot time. So we're basically counting down time. And again, if showtime counter is less than 0, time to hide the laser. Okay, so that will then, we'll call hide laser. We'll do less than or equal to just to be on the safe side. And I'm actually just going to say for our purposes, I'm going to be basically going to be do showtime counter is equal to 0. Just to, make sure it is 0. And that means here what we need to do is the showtime counter is going to be equal to our showtime. So when I start the laser, I set this counter. And at every update, if that counter is greater than 0, then I count this down until it's below 0. And then I tell it to hide the laser. So pretty straightforward functionality. So let's just save this. Let's just jump this into, and then I just want to make sure I'm assigning the laser object correctly. The only thing I need to do now is I just need to go back to my combat controller. And there's 2 things I have to do. I basically need to, I'm going to set up in here a reference to what we need. So again, I'll put it right here. This will be a public. and it's going to be laser control. So I'm going to ask for the script itself. Now I can take the game object that it's on and assign it to this. So this is going to be laser control. This is a capital C. And then we can go down to my Raycast attack. And we're only going to show it if we have a hit. So literally, we're going to basically say, hey, laser control, start laser. It's going to ask for a distance, so hit dot distance. And that's all we need to do. So we've told the laser, so the laser control is its own little system. We tell it turn on, it handles it being shown, and then turns off. So let's save that, and then we can go back into game. See, it's hidden itself, and I can now. And I have done this wrong. Have I? No. What's going on? What have I done wrong? Local scale. That's correct. You see what I've done wrong? Speak up, I can't hear you.
When you did the if statement for checking the show time, the second if statement we must put it inside if the if show time number is less than equal to 0. I think it should be outside of the if show time number. Maybe that's a
No, because this shouldn't be outside of it.
outside the if statement.
Yeah. This is showtime. Let's look at laser. Showtime is 0.5. Let's just for the sake of argument, let's make this public. So we can see what's going on in the editor. What's going on? Let's debug this. Okay, so we press play. Not an instance of an object. What's going on? Laser. Oh, not instance of an object. What we forgot to do, again, let's go back to Unity. What I forgot to do is on player 1, the laser control. That's what I forgot to do. So this is the virtual laser. That's what we want. So I forgot to set the object. There we go. Now it is, it's a half a second, and so you got this weirdness of. Again, maybe bring this back a little bit bigger. Some more space. So it's working now. So, I mean, that's basically what you need to do. You have to make a visual. We're using a cylinder in this case. Could be a plane, it could be another object, but as long as you've made sure that you've got the length of 1, and that's the thing with the cylinder, it has a height of 2. So we had to move it. We had to move it forward a little bit, and had to move it. We had to move it and then scale it to make sure we had the correct scale. So, let's stop. Let's make a duplicate of this. Because I need you on the fire point here. Virtual laser, I'll take you out. virtual laser. Make sure it is correct. And then on here, virtual laser. So now just make sure we got player 2 set up now. That should be. And let me just play this more time. So what's going on right now is that this virtual laser, its position really should be at 000. So when I reparented, it retained its position relative to player 1, and so now I just needed to zero that out. I saw you face palm over there. Yeah, these are it's and by going through this, you're gonna see these are the things that, like, oh, like I knew this was the case right away because when I turned the object, when I turned the turn, I didn't see this right away, and that should have been an indication that something was up. But when I turned this object, I was down over here, which means I did have a laser. It was just not where it was supposed to be in terms of parenting, in terms of how I wanted, So again, welcome to game development. These are the things you have to deal with on a daily basis. This is why you test and you do things yourself so that you can catch these and then make sure, hey, when something weird happens, you can figure it out and tell your artisan designers, you didn't parent it correctly. You didn't do this. This is something that you were supposed to do, so it wasn't your fault. Your code works. It does what it's supposed to do, but your designers and artists have done something silly, ultimately. Again, we could go back in. So there was one other weird thing that we can look at. I think, did I take the Okay, so let's take a look. See how the tank is bobbing up and down? That's not what we want. And the reason for that is, let's go back to our combat. Let's go to the crater. And I told you what would happen if we didn't take the collider off. It's literally putting down the collider and pushing the tank up. We put another one down, push the tank up again. Put another one down, push the tank up. And it would be doing this more if we didn't have the lifetime on here. I mean, if we had a lifetime of like 15, like really big, we would stop hitting the tank effectively. Welcome to game development. I did mention this again last week. So now that is now biting us this week now. I did, in fact, and again on the red one, I just removed the component completely. In fact, I'm going to remove the component, this one. So there's no chance of it being turned back on. I'm going to remove this component as well. And I'm going to we've already done this one as well, and we've done the lifetime. So yeah, so I think the only one that we haven't done is this white one, and we're just going to do the lifetime. Oh, object lifetime, there we go. 2.5. So we've got all our decals in play now. Let's go now. I mean, the next big thing is we've got 2 players. The alternative is to basically, hey, let's make a player. And so, one of the things that we'll talk about with the tank controller is that, is Fire 1 enabled, Fire 2 enabled? I mean, this allows us to go in and build another character type. Now we can do the tanks that just fire projectiles, and then basically with the Fire 2 enabled, we can be like, oh well, the Raycasting attack is on, we can do Raycast attack on the person, the little capsule person, and then the tank has the projectile attacks. So other styles of characters that you could create. The other cute thing that I've seen done, and I'm going to do it because why not? I am going to grab the user prefab. And let me collapse. So I'm going to go in there and I'm going to remove their colliders because I really don't need them. Because this is going to be silly. I'm going to actually also unpack completely. And this is going to be the player. Called player guy model. I'll call it person. I'm going to parent this to. Wait a second. Yeah, I'm going to parent this to the tank controller. I'm going to zero it out. And then I'm going to basically bring them up. We'll make them 0.5. I'll say, I think it's 2 units now. 1 unit. So now we'll just say 1.2. 1.5. There we go. 1.1. There we go. And just for the sake of argument, we'll go into the materials. Where is it? That's crayons. There we go. Give them a slightly different color. And there we go. We have a person in the tank. So, stupid things you can do, things that we can have fun with. I mean, literally when we talk about Unreal Tournament, when you get into a vehicle in Unreal Tournament, the player pawn that you are using is actually so you actually control the tank, and the previous character model that you had gets placed in the tank in the driver's seat, and the tank actually tells that model you move your hands accordingly. Yeah, this is silly stuff that Unreal Tournament does. But here again, we could, if we're doing it, again, so again, this is getting down like possession and other crazy stuff. We'll talk more about possession in terms of like how Unity might do it next term. But how Unreal is using it. Oh, you've entered a vehicle. Well, you possess vehicle. Get previous model, put it and attach it to the vehicle. You're leaving the vehicle. Okay, take your model, detach the model from the tank, and then recontrol the character that you had previously. Did you die? Lol. Rigid body, not rigid body. Ragdoll it. Throw it from the tank and ragdoll it. This is silly. This is what this is more arcadey Unreal Tournament. Whereas Battlefield might just not actually drop a body. Yeah. Battlefield. Particularly the older battlefields, like the World War II battlefields and desert. If you go back further, Desert Combat, they just didn't. It wasn't worth spawning a model into the scene when you were dead if you were the tank. So, but you could, if you were the helicopter, you died. Pop them from the pop the pilot from the helicopter and have it drop. Now that might. We're getting into a weird level of realism that is gory, which can be funny, which can also be inadvertently hilarious at the same time.
Ejector seat in the helicopter.
Yeah. I think one of the funniest deaths I've ever seen. It comes from Sin episodes. So, if you headshot enemies, there's a term called jibs, And these are pieces of flesh when your body has been exploded. In the case of sin episodes, when you do a headshot on an enemy, it hides the head and spawns a brain jib. Singular brain, maybe two, left and right half, maybe sometimes, but it spawns a sprain jib for when you do a headshot. That's again getting into, we can get gory really quickly. Like let's be honest. Like, I mean, I worked at Raven. I worked with people who worked on not Call of Duty, Soldier of Fortune. They went really far with the damage system called with Soldier of Fortune. In fact, you could shoot off limbs and legs and all of that, and that was a big deal, and that caused trouble. The people who so this is now years and years later. The people who I've worked with, public people who worked on Soldier of Fortune are now on the Marvel team. So we've been very much removed from that game to where we are now. And I'll be honest with you, you can go overboard. And when I talk to my colleagues, my team members, and people who worked on those projects, the impression I got from them is that they had a feeling that they had gone too far. That it for all good, for all that they had done, that the players took to that system and took to it way too well, and were finding things about the system, and it basically was the what my colleague had basically said is that the users had found ways to kill people in particular ways to get particular results, and it was very gory in terms of how he described it. Very specific things with a specific gory outcome, and that made him uncomfortable. He was remarkably uncomfortable telling me about that. So you can go too far. Again, if your game is all about blood and gore and guts, it's not going to be a good game. I'll tell you that right now. If that's all you are focusing on, then it's not really a good game. I mean, and how do we know this? I mean, Manhunt from Rockstar isn't that great of a game. We don't talk about it because whatever. It's not a great game. People still love Bully. You do know that Rockstar did make a table tennis game, right? No, you don't. Yeah, look that up. That's so the reason why Rockstar has a table tennis game, because that was their test bed for new technology at the time. And it just so happened that the prototype was table tennis, and they were like, yeah, this is actually pretty fun. And they were like, oh, well, let's make it to the game and ship it. And they did. GTA 5 right now is considered the best golf game in its generation, which is weird. Yeah, if you do take the golf club and hit someone with it, the game does end. The golf game minigame does end. But in terms of physics and reaction, right now there's a consensus out there that GTA 5 right now in this current generation of golf games is the best there on the market. And it's a mini game. Yeah, it's 12 years old. That is sad. That's to show you the state of where those games are at the moment. Golf has waned in popularity greatly since the 90s and early 2000s.
Yeah. MLB for I think 3 EA Sports golf games.
Yeah, I mean, I think partly because golf was really popular in the 90s and 2000s because of Tiger Woods. And since he's now an older golfer, he really belongs on the senior PGA Tour than not on the PGA, but he's still trying to compete. But so here we go. So we set up a Raycast attack. We did extra stuff to make a visual component. We set up the raycast to drop a decal into the scene. Now thinking about it, I probably should have flipped the decals where the projectile was yellow and the laser is red. Oops. Things you think about later on. It's like, oh, we should flip those. I'm not gonna bother right now. It's not a big deal. But the next thing what you might do is make tank versus a human player, or tank versus human AI player. Human AIs that are humans, so it's one versus many. But these are all things. Everything that I'm doing here, you should be comfortable, be able to do. I want to be very clear. Like everything that I've done today and we've done so far, particularly in the combat, you should be able to feel free to do, and it should be okay. I think the big one right now is that we built, the laser control, which is its own little system. It needs to know the object, needs to know how long to show the laser. Again, I made this comically large. I mean, this really should be more like 0.25. Let me get the other one. Save the scene. And I typically, when I save the scene, I also save the project to make sure that everything is always being saved. So now we'll fire. So maybe that probably should be maybe a 10th. I'm on player 2. And we can probably go even smaller. I mean, again, as long as we're above 0.016, we'll go across multiple frames, and that's what we want. We want a frame where it's visible, and then the next frame we turn it off. So like 0.02. So when we get it bound like 0.1 can actually get away with, maybe. But you can see it's flashing. It's not, So like again, 0.5 is probably. We want multiple frames. And is it going to move? Yeah. Is it like too bad of an issue? Not that bad. I mean, we're being gamey. Here is 0.5. And that's looking a little bit better. So this is a play with as you feel. You get the feel for how it is. 0.05 might be too much. I might do 0.03. 0.1 was too much. Wasn't 0.1, 0.2 might be too little. 0.3 might be the right. And this is you play with the value until you find the sweet spot. What we don't want to do is be counting frames. So don't be like it shows up for 3 frames. Well, 3 frames could be, you don't know what that might be. So this is why we're doing this in this particular way. So any questions? How people feel about combat right now? Okay. I'm going to stop the recording here.